In this video, I'm doing another standard minimization problem. And in this problem, I'm going to go through the entire process. I've done a few other videos where I break the process down, but let's just do one where we do the entire process from start to finish. So first of all, we know this is a standard minimization because number one, it's asking you to minimize, C equals. We want the objective function to be all positive, the non-negative objective function qualification, and all of the inequalities are greater than or equal to. So this makes it a standard minimization. So that's the first thing. You have to recognize what it is. So with a standard minimization problem, the first thing that we have to do is create a matrix. And so our matrix will be 1, 1, 1, 80 for the first row, and that's coming from our first constraint, the coefficients of R, S, T, and of course 80. Then we're going to have 2, 1, 0, because there is no T, and 20, and that's coming from these coefficients. And finally, 0, 1, 1, and 40 is our last constraint. No R's, 1S, 1T, and 40. And then, of course, we have to put our objective function in there. So we're going to have 4, 2, 9, and 0. All right, so that is our matrix. But we're not done with the matrices because now we need to do the transpose of that matrix. So that simply means to interchange the rows and the columns. So row 1 is going to become column 1. 1, 1, 1, 80. Row 2 becomes column 2. 2, 1, 0, 20. Row 3 becomes column 3. 0, 1, 1, 40. And row 4 becomes column 4. 4, 2, 9, 0. 4, 2, 9, 0. Now before you go any further, always make sure, double check your work step by step in case you make some kind of a careless error. Just like with the linear algebra stuff that we were doing, it's very easy to do that. So 1, 2, 0, 4, 1, 1, 1, 2, 1, 0, 1, 9, 80, 20, 40, 0. So that is our transpose. Once we have the transpose of the matrix, we create the dual problem from that. And let's do that in, I don't know, it's purple. So the objective function now is going to be P equals 80x plus 20y plus 40z. Remember, that comes from the bottom row. Our objective function always goes on the bottom, and it comes from the bottom. Then our constraints, so subject to, we have 3 constraints. And so we're going to have x plus 2y is less than or equal to 4. X plus y plus z is less than or equal to 2. And x plus z is less than or equal to 9. So it's important to remember that when you are creating the dual problem, and remember, this is called the dual. The original problem then is called the primal problem. Make sure that you are writing it as a standard maximization problem. That's what we're attempting to do here, is rewriting this from its original form. It was a standard minimization problem. And notice that the variables we were using in the original problem, R, S, and T, And now in the dual problem is a standard maximization problem, and we're using the variables x, y, and z. So once we have this, we just proceed as we normally would with a standard maximization problem. And that means that we are going to create a table. So my variables are x, y, z, and well, actually, sometimes I skip this part, but I shouldn't do that for the video. We need to create the system of equations. So the system of equations, we are going to have x plus 2y equals 4, and we need to add in a slack variable. Let's make that r. And I like to make my slack variables the same as what the original variables were in this problem. So we had an r, s, and a t. So my slack variables are going to be r, s, and t. Second constraint is x plus y plus z plus the slack variable s is equal to 2. My third constraint, x plus z plus slack variable t is equal to 9. And then on the very bottom, we're going to have negative 80x minus 20y minus 40z is plus p equals 0. So remember, what we're doing here is just taking everything on the right-hand side, subtracting it over to the left-hand side. And so this is our system of equations. And from that, we create the table. And so our table is going to have an x column, a y column, a z column, an r, s, t, p, and the constant column. And so we have, for the first row, let's just do the x's. 1, 1, 1, negative 80. For the y column, we're going to have 2, 1, 0, negative 20. The z column, we have 0 and 1, 1, and negative 40. The r column will have a 1, 0, 0, 0, s, 0, 1, 0, 0, t, 0, 0, 0, 1, and p, 0, whoops, did that. We have t0, 0, 1, 0, and then the p0, 0, 0, 1. And finally, the constants, we have 4, 2, 9, and 0. So at this point in time, it's always nice to just sit back and make sure, once again, that you didn't make any careless mistakes, like I almost did. So I'm going through and checking my work and making sure it looks like it's just the way that I want it to be. Last thing that we really need to do here, I'll do that back in yellow, is label the active variables R, S, T, and P. Okay, now the fun part starts. This is when we have to determine what our pivot is. So first of all, this table, or tableau, is the initial table. And we know it's not the solution to the problem. It is possible that the initial table could be, in theory, the solution, but as long as we have negatives in the bottom row, it will never be the solution. That's one of our rules. We know that we are not at the solution yet whenever there are any negative numbers in the bottom row. So we definitely have negatives in the bottom row. So to find our pivot row, we look for the most negative number in the bottom row, which would be the negative 80. And so something in the x column, a number in the x column, will be our pivot. And that pivot has to be a positive number. So it could be either one of the three ones. And we're going to take a look at the ratios. So we're going to take a look at 4 divided by 1 is 4. 2 divided by 1 is 2. My pen's not working very well. And then finally, 9 divided by 1 is 9. So we're looking for the smallest ratio, which would be 2. So that means that this will be our pivot. Okay, let's get rid of some of that stuff. We don't need that. And let's take a look at clearing the x column. So this is when we use row operations. And so I want to get rid of that 1 and make it a 0. So I can do that by taking the row I'm changing, which is the first row, row R if you will, minus the pivot row. So row 1 minus row 2. So row 1 minus row 2 would be 1 minus 1 is 0. Going to the y column, 2 minus 1 is 1. The z column, 0 minus 1 is minus 1. The r column, 1 minus 0 is 1. S column, 0 minus 1 is minus 1. The t column, 0 minus 0. P is 0 minus 0. And the constant column, 4 minus 2 is 2. Second row stays the same. That's our pivot row. Pivot row never changes. And then the third row, pretty much do the same thing. We're going to do row 3 because we want to change this number now into a 0. So I'm going to do row 3 minus row 2. So again, 1 minus 1 is 0. 0 minus 1 is a minus 1. In the z column, 1 minus 1 is 0. In the r column, 0 minus 0 is 0. In the s column, 0 minus 1 is minus 1. In the t column, 1 minus 0 is 1. In the p column, 0 minus 0 is 0. And in the constant column, 9 minus 2 is 7. And now finally, got to get rid of that number, negative 80. So I think what I'm going to do there is take row 4 plus 80 times row 2 plus 80 times row 2. So let's check to make sure that works. Row 4 is a negative 80 plus 80 times row 2. So 80 times 1 is 80. Negative 80 plus 80 is 0. In the y column, negative 20 plus 80 times 1 is 80. 80 and a negative 20 is 60. In the z column, we'll have negative 40. Negative 40 plus 80 times 1 is 80, and negative 40 is 40. In the r R column, 0, we have all zeros. In the S column, 0 plus 80 times 1 is going to be 80. In the T column, again, we have all zeros. In the P column, 1 plus 80 times 0 is 0. 0 plus 1 is 1. And in the constant column, 0 plus 80 times 2 is 160. And let's change the outgoing. Here is my pivot. Outgoing variable is S. The ingoing variable is X. So we have R, X, T, and P. Well, good news. We are done because all of the values in the bottom row are non-negative. They're positive or 0. If there were any negatives in the bottom row, we would have to do the process over again. So let's just go right to finding the solution. So I'm going to label these here. This was the X, Y, Z, R, S, T, P, and C columns. So remember, with a standard minimization problem, when we have the dual, we're only looking at these values now. And so to find the value of R, we're looking for R, we take this number 0 and divide it by the p-value. 0 divided by 1 is 0. To find S, we would take the 80 divided by the p-value 1 is 80. The t-value, again, is going to be 0 divided by 1 is 0. And then finally, the C value is 160 divided by 1, or 160. Okay. So this is our optimal value. And that optimal value occurs when R is 0, S is 80, and T is 0. So if I want to write that as an order triple, 0, 80, and 0. All right, that's it.